video is on using the divisibility rules to find the prime factorization of a number and how to write prime factorization with exponents. And the purpose of this video is review for the STAR test. So there's lots of different divisibility rules, but whenever it really comes down to it, what are you going to have to be able to use on the STAR test? And it comes down to just a few rules that are real easy to apply and are real helpful. The rule of divisibility by 2 is super easy. It's all even numbers. So if a number ends in 0, 2, 4, 6, or 8, then it's divisible by 2. And that'll help me break that number down so that I can get to the prime numbers. And 2, of course, is prime. So I can break it down. The divisibility rule for 5 is if the problem ends in a 5 or a 0. So if it ends in a 5 or a 0, it's divisible by 5. And again, that'll help you break it down so that you get to all prime numbers. 5 is prime. 10 is a great way to be able to start breaking down a number that ends in the number 10, or ends in the number 0. So if it ends in the number 0, so even if it's 10,270, that's divisible by 10, so you can at least break that down into 10, 27, and 0. And then you can see if you can break this down further. And then the last one that's helpful with doing prime factorization is 3. And it's a little trickier. It's if the digits add up to a number divisible by 3. So if we take any number, if we take 7, 0, 2, we go 7 plus 0, 7, plus 2 is 9. 9 is divisible by 3. So therefore this is divisible by 3. We can divide it, break it down, get it into smaller chunks to work with. So these are the 4 rules that you really need to be able to work with to break those big numbers down to get them in smaller chunks. So when we're talking about prime factorization, if we take a number like 8, and we're going to break it down, well, that's even, so it's divisible by 2. So 2 and 4, and 2 is prime, as I mentioned. And then 4 can be broken down into 2 and 2. So now I have 3 2's. To write this for prime factorization purposes, I use exponents. And 2 is my number, and I have 3 of them. And so what this looks like is 2 is my base, and 3 is my exponent. And this means 2 3 times. So if I'm multiplying that out, it's not 2 times 3, which is 6. It's 2 times 2 times 2, which is 8. So if I see this, I have to make sure I multiply it out correctly. So 4 to the second power is 4 times 4. So that's 16, not 8. And 2 to the fourth power is actually 2 times 2 times 2 times 2 times 4 times is 16. 8 to the second power, not 16, it's 64. And then we covered 2 to the third power. And then what would you think 5 to the third power would be? Well, 5 to the second power would be 5 times 5, which is 25. And then another 5 would be 125. And that would be the answer. Now this is going to come into play with prime factorization because you're going to break down all of these numbers into prime numbers, and you have to be able to write them using exponents. So prime factorization is, like I said, just breaking down a number, a larger number, into the prime numbers that would multiply together to give you the original number. So let's look at a real easy number, 48. So that's divisible by 2 because it's even. So I know I can take 2 out of it. And then I would have to go over here and go 2 goes into 48 24 times. Then I need to say, well, 2 can go into that again because it's even. Or do I know any bigger numbers? 2 numbers that multiply together. Well, I can think of lots of numbers that multiply together and give me 24. But let's just say 12 and 2. And I circle the prime. I've circled the prime here. And 12 goes to 6 and 2. And 6 goes to 3 and 2. And I've circled my prime numbers. And so now I go to write this. I start with the lowest number I have, which is 2. And I count how many times it's circled. 1, 2, 3, 4. So that's my exponent. And then I say times 3. And then I can recheck this by multiplying this out and making sure that I get 48. So let's look at the next one, 250. Now, what divisibility rule would help me out with this? Well, 10, right? I could use 5, but let's use 10. And whenever I divide by 10, it's just like taking the 1 0 off, right? We've talked about that, powers of 10. And so that would be 25. And then neither of those is prime because they can both be divisible. Look, they're divisible by 2 and 5 and divisible by 5. And so 10 goes to 2 and 5. And 25, what 2 numbers multiply together to give me 25? Well, I know it's divisible by 5 because it ends in 5, and 5 times 5 is 25. So now I write the lowest number I have times 5, 1, 2, 3 times. So I get 2 times 5 to the third. And that's my answer. And if I multiply this all out, I will get back to 250. Okay, so the numbers get bigger. The numbers get bigger. And what do you do whenever you get with bigger numbers? You just break them down little by little. And I know that this is divisible by 5 because it ends in 5. So I'm going to say 5 and what else? Well, I have to come over here and divide by 5. And that's 217. And I have to look at this and I have to say, okay, 5's prime is 217 prime. Well, it's not divisible by 2. And if I add it, 9, 10, it's not divisible by 3. It's not divisible by 5. It's not divisible by 9. It's not divisible by 6. So that must be prime. I can't think of any 2 numbers that are divisible by that. So 5 times 217. And both of those are prime. Usually you'll be able to break it down further. So what is the number that has a prime factorization of 2 to the third times 3 to the second times 5? And this is another way that you might be able to be asked how to find this. Or if this is an answer choice, how can you work backwards to find out what number is correct? So 2 to the third is 2 times 2 times 2. And that's 2 times 2 is 4 times 2 is 8. And 3, this is 3 times 3. 3 times 3 is 9 times 5. So 8 and 9 multiply together to give you 72. 72 times 5 is 360. So if I was given the number 360 and I found the prime factorization of it, I would get this answer. So if this answer is listed with other answers, I can make sure it is 360. But what is wrong with if it said 2 to the third times 9 times 5 as an answer choice. Is that the prime factorization of 360? There's a problem with that. 9 looks prime, but it's not prime. The numbers have to be prime. So you're going to see them, you know, very, very small numbers with exponents or without exponents, but you're not going to see the number 9, you're not going to see the number 10, or any multiples of that. So this has been a video on a quick reminder of divisibility and prime factorization for STAR review.